Hello to my Upward Bound students. This is your instructor, Mrs. Thomas. And today, what we'll be working on, this is our Algebra 2 book. I'm hoping that this is your Algebra 2 book as well. We're going to do section, chapter 3, solving systems of equations. And I want to do a few examples with you. And then I'm going to give you and upload your assignment, which will be numbers from example 4 using substitution and elimination. So I'm thinking about 13 through 24, but I want to give you examples of how to solve using elimination and how to solve using substitution, okay? Because we know how to set up a table using, just say the values -1, 0, and 1. So let me get my pen and let us get started. Okay, so here they have examples of solving the system of equations using a table. And then they also have solving a system of equations using graphing. Well, what we want to do is we want to do what is going to be more efficient for you, because I know a lot of you may enjoy graphing. Oh, I forgot to tell you good morning. Good morning. So let's look at graphing based on elimination and substitution. So for instance, because it is more than just one way to solve. So let's look at 2a. Okay, so we have 4x plus 3y equals 12, negative 6x plus 4y equals -1. Where we're going to do elimination, for instance, what we would do is we will line it up here. Now we need the coefficients to be exactly the same. So since the 3 and the 4, I'm thinking about the factors of 12, I will be able to multiply by 4 all the way through. Okay, so I'm using the distributive property. So 4 times 4 is 16x. And 4 times 3 is going to give me 12y. And 12 times 4 will give me 48. Okay. For my denominator, I'm trying to get -12 here. So I'm going to multiply by -3 all the way through. So negative times a negative is a positive. So that will give 6 times 3 is 18x. -3 times a positive 4 will give me -12y. And negative times a negative will give me a positive. 1 times 3 is 3. Okay, so this will be eliminated, canceled out. Okay, 16 plus 18 is, you guessed it, 34x equals, and 48 plus 3 equals, good. All right, I was just making sure you had it. All right, so that gives me 51. Okay, just making sure. I want to divide both sides by 34. X equals, let me do 51 divided by 34 equals 1.5. Okay, 1.5. Okay, I'm looking, making sure. All right. Sorry guys, I am in the classroom. Okay, so that's 1.5. Now, well, Ms. Thomas, what is y? How can I obtain y? Well, we're going to substitute in 1.5 so we can go back to the original problem if you want to. Remember when it was 4x plus 3y equals 12? We're going to substitute, so where x is, we're going to substitute in 1.5 plus 3y equals 12. We're going to multiply 1.5 times 4. That gives me 6 plus 3y equals 12, like a regular equation. I'm going to subtract 6 from both sides. So that gives me 3y equals 12 minus 6 is 6. Divide both sides by 3. Y equals, you got it, 2. So y equals 2. So we write this. Where's my point? Thank goodness I'm using a pencil. So this is x and this is y, and that is your answer. Well, Ms. Thomas, what if, could you have solved this using elimination? I sure could have. Let me write the original problem down again. Negative 6x plus 4y equals negative 1. Okay, now to solve this using substitution, let me move the 4x in front of the 12. And what I'm trying to do is y equals mx plus b form. Okay, slope intercept. Okay, so here I'm gonna leave the 3y alone. I'm moving the negative, the 4x, and if I move it, the inverse is negative. All right, plus 12. I want to divide by 3 because I want, of course, the variable isolated. I want y to be all by itself. So I end up with negative 4/3, which is my rise over my run. And we know about rises and runs. And 12 divided by 3 is 4. Okay. So if we're going to do y equals negative 4/3 x plus 4, we can do one of two things. We can graph it, or we can start at the positive 4. We go down 4 and over 3, and we can look at the graph. Just say, for example, in the book, the two examples they use were y equals 2x plus 1 and y equals negative 2.5x minus 8. Well, when you graph it, you're looking for the point of intersection. When we did it using the elimination method, this is going to be where both of the lines intersect, okay? So if you use substitution, you go back to your original, you go back down here to this problem, and we're going to substitute in. So now we know what y equals. Y equals negative 4/3 x plus 4, all right, equals negative 1. And you may be saying, Ms. Thomas, this is a whole lot more difficult than just doing, I love elimination. Well, I want to give you a variety so that if some students enjoy elimination, I want you to do that. If you enjoy graphing it, because you know how to graph it and then finding your point of intersection, then I want you to do that as well. So there are too many opportunities for you to graph or either use the elimination method. So there are so many different ways. Okay, so here we're just going to use the distributive property. What is that going to give me? Negative 16x, 16 over 3x, and 4 times 4 is positive 16, equals a negative 1. So it is a little bit of work, but not too much, not anything that you can't handle. All right, so here, let me put this over 1. I need you to help me find a common denominator because these are like terms. Okay, so this is 3 and this is 3. Okay, 1 goes into 3 3 times. 3 times a negative 6 is negative 18. 3 goes into 3 1 time, of course. 1 times negative 16 is still the same. Plus 16 equals negative 1. Okay, well, I'm going to keep my denominator of 3. Negative 18 minus 16 is that negative 34? It is. All right, negative 34x plus 16 equals negative 1. What's next, Ms. Thomas? Well, I want you to subtract 16 from both sides. Okay, so that will give you, let me go up here, negative 34x equals 3. And here, negative 1 minus negative 16 is negative 17. Well, Ms. Thomas, what do I need to do? How can I get rid of that fraction? We're going to flip it or do the reciprocal. 3 over, negative 3 over 34 on both sides. Okay, how about that? That will cancel out because a negative times a negative is a positive. And here, we're going to do cross canceling. Cross canceling. 17 will go into 34 how many times? 2. Okay, that will be 2. So when we flipped it over to 3 over 24, now we have negative, what do we have? Negative 3 times a negative 2 on x. No, we have negative 3 on top. We have 2 here on the denominator spot. What did I do? Ms. Thomas, look, negative times a negative is a positive. All right, help me out, students, help me out. 3 divided by 2, will that give me the exact same thing? Let us see. It does. It does. So this method does take a little bit of time, but whatever you decide is fine with me. If you enjoy the elimination method, you say, Ms. Thomas, the elimination method was a whole lot easier than, of course, the substitution method, then go with that, okay? Because I just want to know what the point of intersection is, okay? So I am determining which problems I want you to practice with, and we're going to do 13 through 20. I'm liking 13 through 20 on that one, okay? I'm flipping the page over. You know, I like to give more than one example. Always, always, always. I just seen this and I thought it was interesting, okay? This is when the substitution method would come in handy, okay? So if y equals 3x minus 4, what I want you to do is I want you to take this 3x minus 4 and I want you to plug it in right here. 3x minus 4 equals negative 2x plus 11. I want you to use the inverse and I want you to add 2x to both sides, which gives you 5x minus 4 equals 11. Then let's move 4, positive 4, all right, which is the inverse of negative 4. So 11 plus 4 gives me 15, and bring down your 5x. Divide both sides by 5. X equals 3. Well, that wasn't as bad as the other one, Ms. Thomas. Well, the other one required a little more work. That's all. Okay. Now that I know what x is, I need you to help me find y. Well, you can go back to the original problem, and you just want to substitute in, because now you know what x equals. So since you know what x equals, I want you to substitute it in. So 3 times 3 minus, I already have the answer in mind, minus 4. So 3 times 3 is 9, and 9 minus 4, y equals 5. Okay, Ms. Thomas, that was easy. I know you guys are going to knock this out. Knock this out the box. I don't have any worries, okay? 4x minus y equals 1. 5x plus 2y equals 24. And I'm getting this from number 2. Just looking, because you can actually use the table, but also if you understand substitution, because I'm not sure if you've already covered this or not, but I want you to do what is going to yield you the best possible answer. If you understand graphing, go with graphing. But if you enjoy elimination or substitution, go with the method that is going to help you understand better. Here, I would not use substitution. It was not as simple as number 1. But I can. I know this is 1. If I can make a 2 here, this will be perfect. I want to multiply everything by 2. 4 times, now I want you to use distributive property. 2 times 4 is 8x. 2 times negative 1 is negative 2y. And 1 times 2 is 2. Okay, let me bring down that 5x plus 2y equals 24. Okay, well, we're going to eliminate. Okay, 8 plus 5 is 13x. And 2 plus 24 is 26. Divide both sides by 13. And 26 divided by 13 is 2. Okay, now I need some help with y. You can go back to the original problem, okay, before I start multiplying, right? So x equals 2, I want you to substitute it in right here. So 4 times, we say x is 2, minus y equals 1. Well, 4 times 2 is 8, minus y equals 1. I want to subtract 8 from both sides. And I have negative y, of course, you know the coefficient is a 1. 1 minus 8 is negative 7. I want to divide both sides by negative 1. And a negative over negative is a positive. 7 over 1 is positive 7. So this answer, the point of intersection, is 2, 7. Okay? And then next week we will talk about whether it's consistent and independent or consistent and dependent next week, but I don't want to bombard you with so much information at one time. So I want you to do numbers 13 through 20, and I will upload this in a few minutes. Have a good day, students.